Hello, and welcome to my last lecture of Astronomy 19. Well, not exactly the last lecture. Since I'm recording it before giving two more lectures in the actual class, I'm just anticipating roughly what I'm going to want to say near the end of the last week, and I think I'll be reviewing some of the things I'll get to tell you in class soon too, but most of this will be new. And I thought I would make it a very coherent storyline. Basically a history of the universe from the earliest conceivable instant where we can even begin to speculate about the physics all the way through to the present time, and even a little bit of a glimpse into the future. So here is an outline of a brief history of the universe. From the earliest time we can conceivably imagine, a time we call the Planck time, 10 to the minus 43 of a second. 0.42 zeros and then 1 of a second after creation, we believe the universe was just frothing space and time in a roiling quantum random mass called the quantum foam. And from out of that quantum foam, some 10 to the minus 35 of a second later, there came a sudden surge, a surge of inflation of space at incredibly rapid speeds. An inflation rate of space so much faster than the current gradual expansion that is absolutely mind-blowing. In just 10 to the minus 33 of a second, the universe will have inflated about 10 to the 50th times. Again, we don't have words for these kinds of numbers, both small and large. 10 to the 50th is the square root of a googol. Essentially, in the tiniest instant of a second, the universe will have become so much larger that it is just simply beyond our English language ability to come up with a name for the number. That will have flattened out space, and then the expansion progresses much more slowly from there. Temperature, very hot. Density, very great. Now, in all the split second of time that followed the inflation, the universe expanded and cooled many times over and went through many different phases where different kinds of fundamental elementary particles were frothing around in it. And as it cooled, some of those elementary particles were able to traverse space more easily. Others found one another and clumped together to make more composite constructions. And so it went on until some 70,000 years after the universe had managed to create at least a few atoms heavier than hydrogen, some atoms of helium and lithium, it finally came to be that the relative strength and power of matter became greater than the strength and power of all the photons of electromagnetic wave energy, better known as light, that had been dominating the universe up until that time. That allowed matter to begin to clump together under the influence of gravity. Gravity pulling clumps of denser matter together. The first clumps to begin to do this were the weakly interacting dark matter that made up most of the mass of the universe anyway. And as the dark matter clumped together, the compression produced sound waves that rippled across the cosmos. But then, just a little less than 380,000 years after the beginning of time, the universe cooled enough that the original ionized plasma now settled down into atoms of neutral hydrogen gas, and the universe became utterly transparent to photons. Once that happened, continued cooling off of the hydrogen gas rendered the visible light glow of all the photons redder and dimmer and redder and dimmer through cosmological redshift until we entered a great dark age, lasting many hundreds of millions of years, where if you could transport yourself back in time, maybe with Doctor Who's TARDIS, and look out, there would be nothing but black. But during that era of blackness that we call the Dark Age, matter continued to clump. And eventually there were concentrations of matter that became so dense that gravity continued to compress them down hard enough that they ignited nuclear fusion and became stars. The very first stars were born probably something like 200 million years after the beginning of time in this narrative. And this was happening in regions where the overall density was greater, so you were getting the stars already coming in little clumped batches. These clumped batches felt gravitational attraction for one another and joined together into larger batches, forming the first very small galaxies. And eventually smaller galaxies joined with other smaller galaxies to make larger ones in the groups of galaxies today. The galaxies as we know them took billions of years to get to the condition that they're in. But just recently, a few billion years ago, the next step in the saga of the history of the universe began. Dark energy dominated over matter, and the expansion of the universe began speeding up once again, faster and faster, starting to isolate all the galaxy groups and clusters from one another at an ever greater rate. Meanwhile, all the galaxies in each group and cluster continue to fall together and merge into single giant elliptical galaxies, so that trillions of years in the future, we have this situation. Every group and cluster having become yet one single giant elliptical galaxy, so far separated from its neighbors that they cannot see one another. They are beyond each other's cosmic event horizon, isolated and alone. The future beyond that is speculative. It may be that the protons and neutrons in the nucleus of every atom will eventually, some 10 to the 35 years in the future, start to decay. But we don't know. But I've given you just an outline here, without any graphics. It's time for the details. And let's start back in the Planck time with a quantum foam.